101. I'm really happy to be here presenting to folks. I guess I'm assuming that most of the people here, since it's Vegetation 101, most of the people here are either engineers or other types of subject matter experts, besides ecologists and landscape architects. But if there are some LAs or ecologists out there lurking, glad to have you too. Feel free to ask some questions or make some points in the chat as I go along. You know, without knowing what everyone's background is, I have to say it's a, you know, it's a pretty broad ranging and fairly introductory topic here. So hopefully if there's some interest in the future, I can provide a little bit more specific information on topics y'all think are useful for you. So, and again, I hate to say it, but there is no easy button with vegetation. So hopefully we can get a few tips and pointers out to you though anyway. So I know with all of our projects, we always hope we can get great vegetation in our project areas easily. We hope it always turns out great. This is First Creek upstream of Tower. Tower Boulevard out in City and County of Denver, First Creek Park. This is only about one season after planting and it's doing great. We'd love to have vegetation that looks great and performs well constantly. This is Wonderland Creek, I think, up in the City and County of Boulder. Again, this is only about 1 year or so after revegetation and it's looking pretty good. So, and then this is the South Platte River, I think at Grant Frontier Park, perhaps in the high water. And, you know, I really wish there was an easy button that I could describe to you that would just make everything work great. But, you know, even landscape architects and ecologists with years of experience, we still cross our fingers a bit when we're doing our revegetation for projects. When it comes to results, it's a little bit of a crapshoot every time. And so hopefully today I can provide some insight to you as to why it is a bit of a surprise with every project and why it's unpredictable. And hopefully provide some suggestions on ways you might reduce the unpredictability and get better results. All right, so what I'm hoping we'll get out of here today, or what you will, a little bit, is some insight into what makes plants tick in general. You know, why do they, oops, let's see, sorry, I'm gonna wait, let some people in. Admit all, okay. Why do people, or why do plants end up where they are? And what are some things we can take into consideration during design that might improve our results and the success? Also some considerations to keep in mind during installation or construction, and then post-project management considerations. So even though that's a very limited number of points to take home, what you're going to find today most likely is that the information I'm providing here is going to be a real kind of a fire hose for you, and or like being in one of those money machines. So hopefully you can, I guess you guys can see all this admit stuff, right? Sorry about that. The money machine thing, the trick to it is just grab what you can. So today, just get 1 or 2 things out of it. If something sticks to your sweater and that's what you take home in the money from the money machine, great. Try not to get too greedy, because what I find is the harder you try to get a lot of stuff, the less you get. So hopefully you'll take 1 or 2 things away from here. Just jot something down, and if you get one useful tidbit out of today, I'll consider it a success on my part. So all right, so first thing is, what makes plants tick? Why do they end up where they are? What makes them sometimes do well, sometimes not do well. I'll be talking about a couple things in basically describing environmental factors that affect plants. You're probably all familiar with the word niche or niche, as some people say. I'm a niche person. Niche or habitat, that's kind of where the plants are happiest. And then talk a little bit about some of those factors that we can influence as part of our projects. So environmental factors include things like, let's see if I get rid of that, include things like living things and non-living things. So we've got the, I kind of wish I wasn't having to do this, but sorry, I keep getting distracted by the admits. I think after a few minutes, I will try not to admit any other people. They can just watch the video. So we have living influence.
We can't see it, Mary. You're clear.
Oh, thanks, Jesse. Okay, thanks. Like I said, I'm Zoom illiterate, so I don't know what y'all are seeing. I must be sharing the app instead of the screen. So thank you. Thanks, Jess. So we've got a bunch of different things that affect plants, right? We've got living factors such as other plants, animals. We got fungi or mushrooms, bacteria, all kinds of other living organisms that are out there in the world with us. In addition, we've got the abiotic factors or non-living things that influence plants. And as you can see, it's air, it's soil, it's salinity or saltiness of both the water and the soil. We've got temperature, which kind of you can consider either climate or weather. That can be air temperature, it can be soil temperature, it can be water temperature. Again, all these things affect what plants you can find in a particular location. And the plants, for each of these factors, have their own, I guess what you could call a little happy spot. So this is just a conceptual look at, say, one factor. Let's say that this is soil salinity. So if this is where my little plants, this is the number of plants that are able to survive, or an individual, how well it's able to tolerate salinity in soil. So down here, we have maybe it's not salty enough. Up here at the unavailable niche on the high end, in intolerance, we have too much salt. So my little plant is happiest right in the little middle area in the optimum range. So imagine if this is one factor, what happens when you layer all those other factors onto the same area. So let's just say again, this is our soil salinity is in graph A. In graph B, we see some other factors. In graphs C and D, we see some other factors that are also coming into play here. I'm going to bring my laser pointer in. So here we have a bunch of other factors layered on. Maybe this is air temperature in the blue. Maybe the red is, I don't know, moisture content in the soil or in the air, humidity. Where all these overlaps, kind of like a Venn diagram, where all these overlap is where we're going to find my little happy spot with each of these. So over here we have, you can see in some instances, they're very narrow tolerances of what a plant, an individual, or a species in general can tolerate in a particular location. So it's this intersection that creates the habitat that a plant is going to feel good in, right? If it starts getting out into these edges, it starts to get uncomfortable. Maybe it doesn't thrive as much. Maybe it, maybe if it's way over here, it'll just die, or it'll never get established in the first place. If it's out to the edges where it's not too terribly happy, then it will maybe not flower or fruit or reproduce well. So, so again, all these interactions together are what affects the plant and the factors that allow it to thrive in our site. So once we put all that stuff together, we end up with kind of a hodgepodge of all these factors. In this case, I just have slope, or topography and soils, basically the landscape. We've got hydrology, and then the vegetation is sort of draped over all this in response to these different factors that are layered in multiples on each other. So hopefully you're starting to see a little bit about the complexity of what affects plants and why we see them where they are. This is just a quick diagram on sort of how it shows up on a landscape. We can have a mosaic of different vegetation types in a particular location. Maybe it's affected by slope, soil moisture, aspect, soil type. Obviously along here, we've got some fringe stuff that's probably mostly affected by water. So we have all kinds of ways that the plants shake themselves out. One thing, so I'm going to show a couple examples here. In this case, what might we say about the various factors that we're seeing here? This is a shortgrass prairie. And, you know, if you're looking at this, like, well, looks pretty uniform. And yeah, it's pretty uniform. So what do we know? We have a fairly uniform topography, which means we probably have fairly uniform slope. The soils are likely uniform. So here's a situation where there's not a ton of variety in the environmental factors or the types of niches or habitats that are available. And so we see a fairly uniform vegetation type here. It's dominated by short grasses that can probably do pretty well with not a lot of water. So it appears somewhat bleak and uniform. This might be maybe that's a rattlesnake sticking in there. I don't know what that is, but so we have some kind of homogeneous conditions in this slide, as opposed to this slide, which has a great mosaic of different kinds of vegetation types. And we can see that the environmental factors are quite diverse here. We have different slopes, we have different elevations, the sun hits the slopes in different ways. You know, we have these coniferous trees that typically require more moisture. So these trees are probably facing either to the north or to the west, where they get a little less solar radiation during the day. Soils are going to affect what's happening here. There's some bedrock showing in some places. So it's a much more complicated system than we saw before. Again, here's another situation where we have the environmental factors are definitely driving what we see with vegetation. I would guess most of you would suspect that the thing that's driving vegetation down in this area the most is moisture. Obviously, it's a riparian corridor, so it's about the wettest place we see. But again, we see the influence that topography, soils, just climate. This is obviously desert, so it doesn't get a ton of water except down in the bottom there. Here's a situation we see a lot here in Colorado. We've got the South Platte River here, just up near Fort Morgan, I think. And as you can see, the vegetation sorts itself out on the landscape based, in this case, primarily based on hydrology. We have irrigated center pivots here, and then we have the river itself, and the rest of it, if it's unirrigated, it's going to be that shortgrass prairie we saw. So we have a lot of complicating factors that go into play with vegetation, and hopefully you're getting a sense of why some of this unpredictability comes into play with vegetation in our projects. Unfortunately, we are not able to discern easily what all the factors are and the various little niches that each plant and each species needs in our sites. It's a very complicated combination. And so we unfortunately are limited to being able to kind of change those conditions or influence those conditions. We're really kind of limited. I'm going to ask you guys, this is your first test to see if you're awake. If you would please in the chat, just type in 1 or 2 words of what you think are some important factors that we can influence. And keep in mind, if you can harken back to some of those biotic and abiotic factors that I talked about, other plants, other animals, climate, weather, soils, salts, etc. Okay, wow, you guys are going so fast I can hardly take it. Moisture. So here are some things, and I definitely focused on things that we can influence. So water, soil type, soil compaction. I like it. Water, fertilizers, nutrients, grading. This is great. Elevations, cover, how people use the site. This is awesome. Water and elevations, good. I didn't see any that I would consider a little out of our control. I think you guys hit it pretty well. Flow regime, I'm gonna go back up here and see if there's a few others. Microtopography, excellent. Hi, Chris, nice to see you. Jim, of course, Jim Wolleman mentioned soil health, excellent. So you guys are hitting all the high points here. So in my personal opinion, these are the 4 factors that we can most influence in our projects. And obviously within each of these factors, we have kind of a range of things, right? Species selection, what kind of species work well together, what works on our particular site, and we'll go into a little bit more of this as we go on. With soil, again, we're talking about soil chemistry, soil compaction, aeration, etc. So we have some control over that. Water, we can have some control over how we use water in our site with regard to the surface water. How do we distribute it through the system? We also have some understanding. We don't have a ton of influence over the groundwater necessarily, although we can do something like use a sheet pile cutoff wall to bring the water table up behind the cutoff wall and make the groundwater more accessible to vegetation. And then obviously we can influence the topography of our site, the elevations, the slope, the aspects, etc. So let's see, on my next thing, I want to take a little break and just see if you have any specific questions or comments. Let's see, let me put my chat so I can see it a little bit better. And feel free if you want to well, I think you guys can unmute yourself if you'd rather. Jesse unmuted himself. Let's see, let me scroll down here and see what kind of questions, if any, you might have. No questions? I'm hitting this completely, knocking it out of the park. That's great.
I've not seen any come in, Mary, but I'll ping you if they do.
Okay, all right. Yeah, I'm not seeing any as well.
Could I ask one out loud? It's easier
absolutely.
than typing.
Yeah,
I was starting to type. I was like, I can't do it fast enough.
No, yeah, please.
I was curious. So you're showing kind of like, there's acceptable or optimal or tolerance ranges for each plant, and that's for kind of like a given factor. How are those determined? I mean, I would imagine to some degree, there's always going to be multiple factors impacting a certain plant at one time. So given a condition of one factor, is that going to influence the acceptable or tolerable range of a different factor? And is that just a little bit too hard to parse out? How do they determine that kind of thing?
Right. Well, let me make sure I'm kind of getting your point here. There are definitely multiple factors overlaying together and that affect a particular individual plant or that affect a particular species. So, right, you can have, and again, it's the culmination of all these factors that creates this perfect little niche or habitat that this plant is happiest in, or that species is happiest in. And it's that complexity of interactions that makes it so difficult to really nail it every time with your revegetation. It's all these things. As to whether one factor influences another factor in some sort of synergistic way, is that what you're getting at with your question?
Yeah. For better or worse, I guess.
Yeah, and I would probably say it depends, and that likely there are some interactions where if you have one factor, and I don't know, say that it has something to do with soil chemistry. In one situation, the soil chemistry is good, but if you bring in some, say the water has a different kind of salinity, it could change those factors and suddenly make things not tolerable to the plant. So there are obviously some interactions between all these things that influence what's going on with that particular habitat or niche for that species. Did I get close to what you were asking?
For sure. I was just curious in general, and I guess I wondered too how easy it is to determine some of those ranges, given that the interactions get so complex in real life.
Yes, it's not easy. That's why there's no easy button. It's incredibly complicated. And so instead of getting tied down or trying to like blow our brains up with figuring all that out, you know, we do the best we can based on what we learn as ecologists and landscape architects and biologists to understand what the interactions are. Certainly we become familiar with our native landscapes and kind of, you know, a lot of it is you just know it's going to work okay or not to some degree, but you can never know everything, which is why it's always unpredictable. We have some very limited tools to improve the predictability of our vegetation success in projects. So that's why it's not a cookie cutter. That's why it's very, very difficult. Yeah, you can do some, I have a comment here. Can we do the questions at the end if there's time left? Well, we're going to do a little bit of both, if that's okay. I do better if I'm answering some questions as we go along, and I think it helps break the monotony of my droning on. Again, I have intended for this to not last the full 90 minutes, believe you me. So we'll have plenty of time for questions as we go along, and then also at the end. But I appreciate the comment.
I have a
anything
question.
else before I move on? Yeah.
For projects that aren't like landscape architect specific, like, I don't know, a road project going in and it's in the arid Southwest, you know, the revegetation on those is hit or miss, and largely weeds take over rather than what was planted. In areas where the landscape recovery isn't as big as, you know, the miles and miles of new road, have you seen anything that's worked time again in the arid Southwest portion of the state to ensure a good recovery? I mean, you don't really have the money for soil amendments or any of those fancy things. It's, you know, the dirt that was there, you harvest the topsoil, you put it back, you do your best with your seeding and your covering. But if you had any insight to promote that better than typical industry standards.
Yeah, well, I wish I wish there were magic bullets. I mean, you're pointing out the limitations that we have. Money for us is a limiting factor, right, as to what you can do and how much you can influence. I certainly think, and we'll talk about this a little bit more in the kind of construction and installation piece, but I think there are things to be done to ensure that the topsoil is adequately stockpiled, stored properly, respread properly. I would always encourage soil tests to ensure that the seed mix that's being applied is suitable. You know, there are some things that can be done to tweak a seed mix. But again, there's nothing that I can say that would be a cookie cutter answer to that. It's like you said, it's working with what you had. And unfortunately in the arid West, as you know, it's really hard to get the vegetation back. It takes a lot of time and maintenance, which unfortunately that equals money, and that's for sure our limiting resource. I'm going to move on. There's a question from Stephanie that I think I'll answer as we. Stephanie, please bring your question back to me. I'm going to move forward, but bring it back when we're talking about design considerations, okay? Which actually is my next slide, design considerations, but we'll pick up Stephanie's question a little bit farther along. So when we're starting a project, one of the things I think we always need to ask ourselves as the design team, and again, I'm maybe wrongly focusing this on our engineering folks that are joining us today. Again, I think the landscape architects and ecologists, have some of these insights and then some. But as an engineer and the design team together, we have to be asking ourselves, what do we want the plants to be doing for us in our project? Because that'll affect our species selections and so forth. Are we looking for these plants just to hold the soil in place, to prevent erosion in the floodplain? Are we hoping the plants are going to work with us on stabilizing the stream banks? Do we need their root systems to help us with that? Do we need the plants to be welcoming to people walking through them? Are we looking for some aesthetics that come with this? There are a lot of questions we can have regarding what we're hoping our plants are going to do for us on a site. So I think these are things we need to explicitly discuss so that we can get it out there on the table and have a better idea of kind of what jobs we're going to put them to on our site. Once we kind of have an idea of that, then we need to know, well, what species are best at doing that? What do we know about various plant communities or species that are going to do the work for us? And then finally, well, can I provide suitable conditions for those plants? And again, sometimes we find that we are asking our site for too much. We cannot necessarily create the conditions that are suitable for the plants that we would like to have, in which case we need to go back to the start and maybe rethink our expectations about the plants and the functions they're providing on our site. So when I'm talking about some of these functions, and thank you, Jim Wolleman, for this this slide here. I think this is a great example of how important species selection can be when we're talking about function. I don't try to read the species types. The intent of this figure is just to show that different species have different root depths, and it's not always based on the size. I like this one. Look at this little guy. It's not always based on the size of what you see, but it's really about what's down below here. And I think this over here, this is turf grass, this little fuzz, and it's trying to show you, your typical bluegrass sod has virtually no root mass below ground. It probably provides great, great protection for just surface runoff. But if you're talking about bank stabilization and helping stabilize your maybe locking some riprap in place or such, these other longer rooted species would be more useful to you. I think this also shows the importance of topsoil preparation and even subsoil preparation to create the right conditions for your root systems to do all the work that you might be asking them to do. Let's see, sorry, there we go. Again, for soil, mentioning soil, this is a factor that we have to have in mind when we're doing our designs to understand what types of topsoils we have, what's influencing the compaction or the aeration in the soil itself. And again, there's no cookbook on how to do this, although I have to say that with Jim Wolleman and Muller Engineering's help and others, the Mile High Flood District does have a topsoil management guidelines that we would hope you could visit our website and look through some of that. It has some excellent information about soils and topsoils in general and topsoil handling, and it's a great resource. So it will improve our ability to work with this single factor in our projects and improve our results if we can internalize some of those some of the guidelines that are included in there. Again, when we're talking about our site, we need to know the plants we're looking for. We need to know whether we can create the conditions with the soils and the topography, and we also need to understand the water. And that can be surface water, it can be groundwater, and it can also be lack of water. So we really need to understand where we are in a particular system, and how that affects what we can expect for our plants. So in this case, it's what they're calling a gaining stream. So the groundwater is discharging into the stream, in which case you've got your plants have an easier time to get to the water table and have some access to hydrology. In this system, it's a losing stream. The stream is actually recharging the groundwater. And so these plants, they're at the same elevation, but you would have to choose different species here as opposed to over here, just based on the type of water table you're at. So these are really important considerations. This is what we find a lot in our systems, is just the water table really doesn't have much influence on our site at all. It's all driven by surface water. So these are really important things to kind of understand your site before you start thinking about what you're going to plant there. Again, we also have to have the understanding of the interaction between the water and the soil. Again, we had that groundwater that I was showing before, but then we also have this extra capacity in the soil to hold moisture, and it will wick up the moisture into the soil a bit. So it's not necessarily saturated, but you do get moisture soil. So again, this is that interaction that we were talking about, the different factors. Your soils affect the moisture, affect the plants, and it's a lot to keep in mind all at once. But just to show an example, we see the capillary action drawing the moisture up from this. It's probably a good foot in this photo here. And again, the height of this fringe is going to be dependent on the soils that you're working with. But this is, again, really important in understanding what you can ask of your plants and what types you can use. So this cross section here is a real conceptual type. I'm sure a lot of you have seen it in the plans that you've been working on with your landscape architects and ecologists. This is just a very conceptual view of if we have the water table or zone of saturation. In this case, it's shown as being perfectly level. This may or may not be the case, right? We know it could be undulating through here or dropping off. But this is just kind of giving a quick survey of where the water is in relation to the ground surface, and then what types of plants or species that we could expect to tolerate these conditions. So we've got the little herbaceous types that are closest to the groundwater. Most of you probably know trees and shrubs can become oversaturated with too much water, so that's why we don't typically see them in places that are super close to groundwater. And we start to see herbaceous grasses and forbs or flowering plants and shrubs coming in as we get a little bit higher from the groundwater. And the farther away we are, here we're showing the groundwater is maybe up to 10 feet deep. So this is where we start planting trees, some deeper rooted shrubs. We have slopes that are coming in to play here. So I highly recommend for almost every project this kind of thinking, even this diagram. I know it may be one you're using again and again and again, but we have to be looking at these considerations with every project to make sure that we are actually putting the specific thought to it to figure out where these hydrologic zones are. Most hydrologic zones you'll see in most projects, people typically divide it up into 3 or 4 zones. So this first is, about 0 to 1 feet above groundwater. You've got about 1 to 2 feet above groundwater. And then this next one, 2 to 4, and then 4 to 10. The reason these are broken out like this is these are kind of where we see some natural breaks in species tolerance or even plant type tolerance. So again, trees and shrubs, they're going to be happier, probably in the 4 to 10 foot above groundwater than right up against the creek. So we need to be having these conversations. And I'm going to show you some examples of projects where we very specifically mapped that out in our typical cross section. So here's a cross section. We've got the stream here. Obviously coming up, we've got some buried soil riprap, some plugs in here. We've got a little swale off to the back. And then as we head up, way back over here, you see the hint of a tree. What we've done here is the darker blue line here is showing the groundwater. And then I've shown here what we might expect for a capillary fringe with the soil, excuse me, soil getting moistened from the groundwater and a little bit from the surface water. But what we did here, and I have to thank Jesse Clark with Stream for creating this figure, but we've got the zones shown here, zone 1, zone 2, zones 3 and 4, and we have the depth to groundwater showing here. So we spent a lot of time trying to predict where we think the water is going to work in our site. And this is along Cherry Creek in the city and county of Denver. We spent a lot of time with this, and it's important because it really helped us decide what we were going to plant and where we were going to plant it. Here's another example. It's a typical cross section here of a very simple system. I don't show the groundwater here, but you can imagine that at least here, it's a fairly shallow groundwater. This is a pretty narrow thing here, but what we did with this was then took it and we marked on the plan sheets, and this is from Sulphur Gulch. This is a Muller engineering project, and I think ERO Resources helped with this, with the planting plan. But the moisture levels are diagrammed here based on those hydrologic zones. So we translated it, the team translated the cross section and the anticipated water levels into the plan view. And we really have to be doing this with every single project. Again, another example, this is a typical cross section from the West Fork of Second Creek. It's a much steeper system than we saw in that other example, which means that when we sort of went through our assumptions on what would be wettest, we ended up with a much more narrow and less diverse planting area for our the species that we think need the most moisture. Everything else is going to be kind of your typical upland seed mix with maybe some shrub seeds thrown in. All right, we have another kitty pause for some questions. If it's okay, I think I'll go back to Stephanie's question in the chat. Let's see, someone just boop, boop, boop. Stephanie's question is, if there's so much uncertainty, do you recommend higher species diversity in seed mixes and/or planting plans to throw everything in to get it to 70% sooner than later? I assume 70% cover. And if so, then what is a good minimum number of species to select? Oh, yeah, so that's a great question. There's a couple ways you can deal with that. One is to do what you suggested, which is increase the number of species in your plant palette, either seeding or planting, which basically allows you to cover a broader amplitude of conditions you might find. So if maybe it's a little off, you have one species that would be happy over here, and then you have a bunch of other species that help fill in the gaps so that wherever your site actually ends up, you know you have somebody who's happy there. That's one way to do it, is by increasing the species diversity. Another way to do that is to use species that maybe fewer species, but that you know they have a broader amplitude of what they can tolerate. So there are some species that, and I'll use a non-native example, but smooth brome, something like smooth brome, which is an introduced grass, that stuff will grow a lot of places. It has a wide ecological amplitude of tolerance. Some native examples, western wheatgrass has a fairly wide amplitude as well. I will say typically with our natives, they are more narrow in their niche and habitat tolerances, which is why the invasive weeds have the jump on them, because weeds typically have that broad tolerance of factors. So yeah, I would say for sure increasing your species diversity is a good thing. but you also want to find those key species that have that amplitude, and natives, obviously, but you want a combination of those. So you have some core heavy hitters. They're going to work in most cases, and then you have the other stuff that helps fill in the gap and provide that diversity, which frankly, the species diversity in your sites helps your site withstand disturbance or changes in moisture over time. You have a community that can sort of move and flux based on those species that are in there. Some are going to do better some years, some are going to do better in another year. So yeah, having that diversity helps you kind of roll with the punches as your site conditions change. So that's a good comment or question. From Carrie, we've got another roadway project, yikes. Looking at soil conditions and nutrients, which is typically just grass. The question is, do you think we need to look at depth to groundwater for just grasses? Excuse me. For roadway projects that don't have access to any groundwater, no. You're just looking at dryland species in that case, and it's really not part of your consideration. The comment about the groundwater and so forth is definitely targeted toward stream channel projects, where many times we're asking those species to help stabilize the bank, toe the bank or something. So we want to understand the water in that case. As you can imagine, upland species, they just have to deal with the surface water they're going to get. So you don't need to worry about too much about that. Next question from Alicia: how do you recommend that contractors determine their hydrologic zones for vegetation, and is this a significant added expense to them? I don't think it's a real added expense if you have a knowledgeable, and I was going to mention this later, but we should absolutely be having, as best we can afford, landscape architects and ecologists on our teams that can answer these questions. I wouldn't expect a contractor necessarily to determine, but I would expect a consultant or a subject matter expert to provide some information on what the anticipated hydrologic regimes will be. And that can frankly be confirmed in the field, and that's a tip later, confirmed in the field before planting or seeding, is making sure that you check that your assumptions are correct and that you're seeing what you need to see in the field. I am going to move on. We'll hit some of these other questions. And yes, let's see. Jill just posted to the chat. Thank you, Jill, for doing this. Link to the Mile High Flood District topsoil guidance. So appreciate that. If you have not seen that before, I recommend going to it. It's a valuable resource. Again, it's a fire hose, so you got to pick and choose what you can and just build on it over time. But it's a great resource. All right. So we've talked a little bit about design. Now let's talk about installation, which goes to some of these, what I was just saying about determining in the field what's happening out there. So as far as installation, excuse me, I'm not used to talking so much. I'm gonna admit some people. So we've decided what we're gonna be doing with our plants, and I this next section is more related to God, sorry, this admin stuff. It's just a real quick spin of, and again, it's focused on engineers, so I apologize for those of you who, this is Vegetation 101. So I just kind of want to give a quick run through of what you might see in the field when you're installing specifically different plant types. When people are talking about different size containers and different ways to do seeding and so forth, kind of talking about the materials that you might see when you're out on site. Once you, excuse me, once you've decided what you're going to be planting, well, what does that look like, and what are some things you can look for when you're out there? So just real quickly, again, I think you've probably all seeing the type of plant material here. This is a plug, just in this case, a wetland plug. It's a grass species here with a wetland plug. These things are great, but you can imagine, given the word wetland, that these things are limited in their applicability in our sites. Obviously, this again is where it's so important to understand our hydrologic zones. This little guy needs to be moist. This little root mass needs to be moist pretty much all the time. So again, we're going to be limited to where we would put this kind of material. It's, you know, obviously it's common sense, but it's also the reason why it's so important to check your site conditions prior to actually planting. Make sure that you've got a knowledgeable person coming out on site and confirming that where the locations are shown on the plans are actually going to work with the hydrology for the species that you've selected to put there. All too often, we end up, you never hit it right. You can design this thing to the nth degree, and it looks great on a plan set, and darn it, the contractor can build it exactly the way it's designed, and your hydrology, your site conditions will vary from predicted. It's just, that's how it is. We can't control it all, and so we have to field confirm before we put in stuff like this. You miss this by 2 inches and they'll die. You know, it's that narrow of a tolerance in some cases. So again, it's the types of materials you plant. It's just so important, again, to get that vertical elevation nailed when you're actually planting the things. Here's an example of just, you know, you've all seen this. The wetland plugs, both in the channel, and then there's some little grasses here up in the Overbank area. This is Wonderland Creek. Again, I think I showed a photo of it earlier, up in Boulder, right after planting. With the trees and shrubs, these are just types of containers. And, you know, when you guys are talking and seeing these things, these are 1 gallon, 2 gallon, 3 gallon, 5 gallon, 10 gallon, 25 gallon size plants. A lot of these types of plants are more in your kind of maintained landscapey area that get planted in shrub beds and landscape trees and so forth. We do use some of these larger container materials in stream restoration projects or in riparian corridors. But generally, if we're working in an unirrigated area, again, we have to be so careful about where we put these things. If this species, in this 5 gallon pot, is a type of species that when it's mature, its roots go down 5 feet or so, and it has to hit the water table, what do we do in the meantime if we're planting this thing and it's only got, you know, what is that, about 1 foot of a root ball? How do we get the darn thing to grow such that it can persist over time? And that's where either we use temporary irrigation to help get it jump started. Maybe we don't use a potted plant. We include this as a seed in the seed mix, depending on the species. So that's another consideration is, are you trying to get these things in and going immediately, or do you have some time to let some things sort of develop as site conditions change and let them sort of find their own way through to the site? One thing we've been doing more recently is, instead of using these traditional pots, I recommend, when you can, working with your landscape architect and ecologist, to talk about using deep planted, there's shrubs particularly, and deep planted herbaceous plugs, grass or forb plugs. These are smaller on the top, but they have much more robust root system for the size of the above ground material. So you can plant these guys a little deeper and have a little bit better access to potential soil moisture in there. So it's something to consider instead of the traditional pots that you go out to your landscape company and find. Sometimes you have to special order or contract grow plant materials of this type. But it does increase kind of where you can put those things in some cases. Bald and burlap trees, we've all seen these, probably have some you might have planted in your own yard. These are nice. Typically, these types of trees, you would want to have some sort of irrigation to help them along. It's uncommon unless you can get the root ball deep enough to touch that saturated soil or the groundwater. You have to have some supplemental water to get these guys to persist. So it's either temporary irrigation or it's a watering truck for a couple years to kind of let them catch their breath and then send their roots down. One thing with these balled and burlapped trees is you do want to make sure when they go in that you take off all the junk. This poor little tree, somebody stuck it in the ground without removing the wire cage or the burlap around it, and the poor little roots are having a tough time doing anything. I bet somebody just could almost pull this thing out of the ground without trying much. It probably fell over. It's probably how they figured out it was planted incorrectly. Although, frankly, this material at the top should have been a hint, right? When you're doing your inspections out there, make sure all this junk is off. That'll save you a few $500 worth of installation and plant materials there, if you make sure it's done right. One thing we've been using quite a bit as well these days that I like a lot are some of these bare root stocks. These are some of the species, especially cottonwoods, are the type that you can plant a little deeper, and again, accessing that soil moisture, and those can work fairly well in some situations. They're somewhat limited, but it's always an option. So that's some of the plant stuff. The next thing I think personally is the most important thing we need to work on as an industry, and that again speaks back to the soil topsoil management guidelines. And I see that Stephanie also posted, or somebody posted, the CDOT specs for topsoil. I do find CDOT, they do a lot of research and they do have good resources as well. I do double check with them a lot. So this next piece, absolutely try to find all kinds of information that you can to see what's applicable to your site. But if we can't create a suitable growing medium for our plants, they will not, they won't thrive. They either won't establish or they'll poop out after a couple of years. They'll just give up and say, this is terrible, I'm out. Or you'll end up with species that you didn't intend to be there, the weedy species, which is sometimes worse than no species because you have to fight so hard to get them out if you're trying to redo anything. So certainly one of the biggest problems that I encounter in construction sites and dealing with revegetation is over-compacted soils. It really doesn't take much to create a brick that the plants, when I first got started in this business a long time ago, there was a seeding contractor. I think all he did was seed, and his little business card, I kept it for years and I don't have it anymore. I wish I did, but his little tagline, his motto was, "You can't grow grass on a brick." And I carry that throughout my career. Darn it, you can't. And sometimes we're just creating bricks out here with our equipment, recognizing sometimes we have to do soil compaction to create stable soils, but we need to recognize the importance of checking the compaction throughout the site, not just haul roads, those and staging areas. I mean, obviously those are super prone to compaction, but other spots throughout the site can become compacted and it may not be readily apparent. So I highly recommend taking a piece of rebar out with you and just jamming it in places to see if things are decompacted. And certainly chiseling the compacted soils, it's a must. And I like this picture because these things mean business. Now, I've seen some equipment that's occasionally used to rip soils, and it has kind of some little, seems to me a little flimsy tines behind it that kind of scratch the soil a little bit. But these things are going to be down in there. These are chisels, and you're going to get the depth you need. to get those soils decompacted. Obviously, it takes a lot of work. It's not just one pass, it's a couple passes. And then you still need to chop up the soil, decompacted soil after that, so that you have the right texture and sizes of soil materials. Again, one of the things, the vegetation, the seedbed prep after you decompact, you absolutely need to be thinking about making it a great place for our little seeds to grow. You don't want it even some minor surface compaction. You just have to have a nice friable seed bed. And again, this is where your landscape architects, ecologists, certainly your contractors, this is where a good seeding contractor will help you determine whether the seedbed prep is adequate. The downside to compaction, and again, thank you, Jim, for a slide I could steal, but you know, it's perfectly intuitive. When you have compaction, your little plants aren't very happy. They can't get those little roots down there. They're trying so hard, but they can't, and they just don't thrive. So we need to have room for these guys to stretch their legs and get well established. I can't stress it enough, and it's so hard to go back. Once you've moved on and seeded, you've put your erosion blanket down and you've seeded, it is so hard to go back and address compaction problems. So do it right the first time, make sure it's done, and then move on. Next thing is, you know, we have a great seed bed, and then how do we make sure we're getting it properly done? And this is where I think it's important to have a very knowledgeable contractor, revegetation contractor, who follows your specifications. I was talking to some contractor once, and he said, you know, we were talking about seeding and successes and stuff. And he said, yeah, well, you know, what I do is I always just throw in a couple species, you know, like a temporary mix that they don't ask for, but I just throw it in, and you know, it looks good, really good for the first whatever. And it's like, okay, please do not hire somebody who will just throw something in without you knowing it. You have specifications, you have seed mixes for a reason. So you want to make sure that your contractor understands that they need to follow what you're saying to do. This is what's called a Brillion seeder. The little seeds come in here, they fall out. This little thing here kind of creates a little hole for the seeds to fall in, and then back in here there's another little thing that kind of closes everything up after the seeds go in. You know, I don't know if you've noticed, but on our seed mixes, we are very specific about sort of how many pounds per acre we want and so forth. And it is critical that your contractor who's doing the seeding understands how to calibrate the orifice. You know, this little hopper, the seed hopper here, has little openings that, you know, plop the seeds out. So these things have to be adjusted and calibrated to the right opening size, and the drill seeder has to be moving forward at a certain speed such that you're getting the seeding rates that you've specified. It's very easy for things to be either over, too much seed or not enough seed, depending on the adjustments. And I'm wondering how many of us, when we're out on a site with a contractor, how many of us confirm that they actually are calibrating their machinery and their seeding speeds properly. It's not something we really talk about too much. So again, it's something to be aware of. There's a lot of things that make a huge difference. Having a contractor add something that you didn't specify is one way for things to go wrong. And then having equipment that isn't properly calibrated or in good working order is another way for things to go wrong. So, and again, I'm not suggesting that every engineer or designer needs to be knowledgeable about all this, but there has to be someone on the team who's out there making sure it's getting done properly. The engineering inspectors or your ecologists getting out there when the seeding's being done. All right, and then again, this is just different ways to broadcast seed. You can imagine you're not going to get very accurate seeding rates here with this kind of situation. So this is more just like, you know, let's spread it out and hope it works, which is sometimes all you can do in a site, right? Again, we could have all these really, like these seed mixes that have these little tiny amounts of seed, and we say you're supposed to have 0.1 pound per acre or whatever. You know, good luck getting that, but at least you have some place to start. But again, check and make sure you're getting the seed that you specified, and check and make sure that it's going in the way you said it should. Quick little pause for any questions where we're at. And what time is it? 12. Okay. So I've been going about an hour. All right. Well, I'm almost done. Any quick questions, or I'll just move on? Chat or verbal are welcome. All right. I'm moving on. Oh, sorry. Dave Skudis, can you mention what to think about in a site with changing, urbanizing watershed where the hydrology will change? Yes, I will mention that. In fact, I'm going to mention that in the next section. So that's a great, perfect segue to the next section, the final section, which is management, vegetation management. And this will go right into it. So let's say, you know, by gosh, Bagam and Bagora, you've designed everything properly. You nailed it on getting it in, and it's like, wow, this is going to work. So it's the day after installation. Well, what's next? Do you get to just, you know, wipe your hands and call it a day? Or do you have to really commit to the long term? I think you guys can guess that you have to commit to the long term. We're getting better at this as we go along, and that's doing a better job of managing what we put out there. Some considerations regarding management include, I'm going to touch on these just briefly, making sure that the vegetation you install continues to perform the function you intended it to do, and in a way that doesn't become a detriment to your project. So we certainly understand the importance of in values when we're designing channels and thinking about plants and so forth, and we just want to make sure that over time that the plants and the community that we've installed doesn't become doesn't grow and grow and grow and turn into something that is defeating our project purpose, which is you know, typically water conveyance. We don't want it to become an impediment, so we have to think about that, which means we have to think about maintenance. Well, what do we do to sort of keep our vegetation where we intended it, in the condition that we intended it, make sure it has long-term functionality and survivability? How often do we go out there and kind of reset or do the maintenance? There's a difference between an establishment plan, which is how do I get to what my goal is for the site, and versus an adaptive management plan is once I've gotten my vegetation established, how do I keep it there? To me, two different things. But real quickly, this is something that I've really been trying to focus on in my profession and working in stream corridors, and that's understanding that plants, they change over time, right? I mean, it sounds like a no-brainer, but how often do we go back to our sites and really see what's happened over time and understand what's needed for the long-term maintenance? And I'm just real quickly gonna, this is an ecological thing that sort of visually shows, here's our post-construction pre-planting project. We do all our work, we come in and we seed stuff, and after the first season we might have a few little tiny guys, some herbaceous stuff. Over time and over the years, this can be 5 years, 10 years, you start to see things maturing. You might see some volunteer species coming in. You know, we get those weedy trees. We have some willows that come in. We start to see our shrubs get overgrown. And eventually, I'm sure you've all seen it in some of our stream systems. You have these overgrown urban streams where it's just so thick you can hardly beat your way through it. The trees have overgrown everything. You don't have much herbaceous stuff in the bottom because the trees provide so much shade. This is typically this overgrown sort of this climax community situation. That's typically not what we want to see in our stream corridors for the most part. We're kind of happier back down in this area where we have some moderate trees and shrubs. It's not totally overgrown. We still have good ground cover to maintain soil stability during flood events. So what do we do here? Well, fortunately, thank goodness, most of the species that we're looking at doing, at using in our projects, and again, I'm particularly thinking of riparian and stream projects, our communities are adapted, or they're used to, they like these disturbance events. Typically in a riparian corridor, you kind of start off, you've got post-construction, you're getting into your your little herbaceous plants and something, and oh, there's a flood. But a lot of these guys they'll tolerate it and they'll keep growing. At some point, you're gonna get another event and it sort of resets things back. This climax community in riparian areas, we rarely get to because we have continued disturbance. We have flood events, we have fires. Back in the day, we had buffalo that would come in and chew everything up. So in our urban areas, we as managers need to be that disturbance to our system so that we're resetting our plant communities back to our design intent. And that's where the management comes into play. Excuse me. This is also where we need to be thinking about, to Dave's question or point about the sites changing over time. This little diagram here, let's see, let me go back. This diagram just kind of shows everything headed in one direction. Well, if we were looking at this site, say it starts as a dry gulch, and we're going in, and we see this a lot in developments where a development's coming in and they're creating a new kind of system, stream system out of scratch. In some cases, we're in these upland, really headwaters areas. They don't get any moisture, but we're coming in with a development. We know that over time, the surface water, the impermeable surfaces are going to contribute water to that system. So what we planted to start with is in a dry upland system, but over time that hydrology changes and it becomes more and more moist. Eventually we can actually get perennial flows in some of these creeks. We've all seen it over time if we've been here long enough. Back in the day, Cherry Creek upstream of the dam was an intermittent stream. Probably half the year it was a sandy wash, and now you go out there and it's perennial, all year round. It's no longer going subsurface in the winter. So how do we deal with that? Well, that's where some of this management, adaptive management, comes in. We need to be able to go back out to the site and either do something to reset our system to reflect where it is now, or, as I can't remember whose comment it was, or we bake into our system a little bit of flexibility. If we do have broad species diversity in our initial planting, some of those species may not be happy at first because it's a little dry for them, but as it gets wetter, they can start to flourish and say, okay, finally it's wet enough for us. And the other little upland guys who were happy when it was dry, they're kind of like, we're going to move up here and we're just going to stay on the upper bank. You guys can have all that wet stuff at the bottom. So you can address some of it with your initial plantings, but frankly, for large differences, you're going to have to go back and do some replantings to reset the system to better reflect what you're seeing over time. Again, it's a long-term commitment, but if the vegetation is important to your project, and how it functions over time is important to your project, then you need to be following up with it over time with maintenance and management for sure. So let's see, let me move on. Here's a good example of some of what we've been seeing with this succession, how things mature. Again, Wonderland Creek, and I have to give Dave Skudas photo credits on pretty much everything I think I've shown for site photos. So thanks, Dave. This is also Dave Skudas' project, design project with Mile High Flood District and City of Boulder. And Jim Watt had a lot to do with design and following this through to construction. But this is a great series of photos and how things change and what we need to do about it. Planting, post-planting. This is 1 year later, looks great. This is probably close to this, is probably what the designers, kind of what we're all thinking, oh, this looks pretty good with the vegetation here, the trees, we know are gonna get bigger, but this looks pretty good. And it's only 1 year later. And then another year, well, this is looking good too. Look at these trees. Look at this little tree. He's really taken off. We're starting to see some stuff. This looks pretty good. We still have some water. It's all good. Okay, 2020. Whoa, wow. Okay. We're only like 3 or 4 years into the system, and we no longer have open water through here. We've got tons of vegetation coming in. So at this point, we're already to the stage that the city and the flood district are working together to come up with an adaptive management plan on how to make sure this system doesn't get overgrown and have reduced flood conveyance. You can tell that any problems with conveyance could have some really adverse effects on adjacent properties. So it's very important to keep this to design in values and keep the conveyance going such that it continues to meet the management objectives. So in this case, unlike the one Dave was talking about where we're going from dry to wet, in this case, we're kind of going from, oh, it's pretty good to overly, it's getting too wet, too overgrown, so we have to go in and do some management over time. Let's see, quick question. Dave Skudas notes, this site has irrigation. It does. I would posit though that a lot of this herbaceous vegetation would be coming in regardless, whether it's irrigated or not. The trees obviously are thriving from the irrigation, but it's wet enough that in this particular location, they might have done pretty well on their own, even so. The question, Doug has a question, and it's a good one. Are those weeds or the native species that grew more than anticipated? For the most part, these are actually desirable species, and they are growing. They're being true to form. Where there's a lot of water, you get a lot of vegetation. So they are just thriving in this situation, and our job is to kind of keep an eye on them and again, beat them back every now and then. We're going to have to reset. If you remember those little swirlies. We're going to have to just go back every now and then and reset this system to a little bit of an earlier stage, such that it gives us some breathing room. Whether it means coming in and doing a bunch of vegetation whacking back, that may be the case, or it might just be, keeping an eye on the trees and shrubs. Yeah, urban gardening, that's what it is. So I'm going to wrap it up here, I think. Again, just to remind you what we were looking for to get out of this. Hopefully you got one or two things about what it takes, what makes plants happy. What do they need to be in their little happy spot? Some things to think about during design, installation, and some management considerations. For me, what I would hope that you got, hopefully, is that Vegetation 101, it's complicated, super complicated, and that's why it's unpredictable. That's why it's hard. And that's why we need to include landscape architects. Here's my plug, landscape architects and ecologists on the team to help us come up with our best vegetation solutions and results. And by the way, landscape architects and ecologists, they are not interchangeable. Sometimes you have someone who is an expert in both schools of science, but they're not interchangeable. So I just want to make sure that's clear, that they each have different specialties, different skill sets, and I strongly recommend that they all be included in your multidisciplinary design team for our stream projects. So with that, the final little kitty paws. Let's see, what time is it? Wow, geez, oh Pete. See, it's so good I only planned for a short presentation. What other questions do we have here, if any? You've been great about pitching them to me during the presentation. Got one here. Behan is wondering if there's a stream restoration ecological modeling software for practitioners to account for all the parameters or have an optimal outcome, or is there a similar tool? I'm guessing maybe this is coming from an engineer. I'm not sure, but gosh, I wish there was a model that would, kind of plunk out some of these answers. I'm sure there are some tools out there that can help with that. But I have to say, because of the complexity, it's virtually impossible to model to help with that. That's again why it's so important to have subject matter experts on your team who are familiar with the sites they're working in. I have had some experiences with people coming from other parts of the country and doing some projects here, designs and so forth. And I can tell you that there were some disappointing results just from a lack of understanding of the local ecosystem that the projects were located in. So let's see, HEC-RAS for engineers. Yeah, we need a HEC-RAS for ecologists. If we had one, that would put us out of business. But let's see. Jim has a point or question regarding native seed mixes. Are there different schools of thoughts on the benefits of adding an annual starter species for quick growth? Yes, Jim. As you might imagine, with anything related to complicated systems, there are definitely different schools of thoughts. The concept Jim's talking about is using what's sometimes called a nurse crop, where you have a sterile annual species like a oats or some kind of sterile ryegrass that you plant, and ostensibly it stabilizes the soils until your desirable species have time to get established. And yeah, there's different schools of thoughts. I think it's one of those things where it's going to be site specific. It's going to depend on your soils, on your hydrology. On the plus side, the nurse crop can help provide some stability. It can also provide some shading that might help your seeds to get going. On the downside, they can compete for scarce resources with your desirable native plants. So again, I think that's a conversation to have with your team on a site-specific basis. Behan asks, would you ever consider weeds and or non-natives as nurse species? I would not. I would say that categorically. I wouldn't consider weeds a nurse species because, boy, once you let them in, they're going to take over, right? We're trying to keep those out. We want to give our native seeds the best shot we can.
Hey, Mary, if I could jump in real quick.
Yeah, Josh.
So I think, so we've seen this happen, not where we planted this species, but kochia came in and was heavy in one of our sites, and we just had the contractor kind of weed whack that kochia down to 6 inches so that those bottom branches still provided shelter. So we were still controlling the species, and it operated as a nurse crop, but didn't it wasn't part of the seed mix. And so I think if you think about it as a way to factor into your adaptive management process, then you can leverage those weedy species to serve that purpose without it being part of the seed mix.
Well, and I appreciate that comment. And again, it's going to be site specific and definitely done in consultation with your ecologist who knows sort of what the benefits or the potential adverse things could be. Certainly, some of the things that could happen in that situation, you want to be careful that you don't just leave the cut kochia on the ground that smothers everything. So you want to have somebody on the team who can help walk you through these things and can take advantage of a situation if it's there to be taken advantage of. But again, I guess I wouldn't have deliberately used that approach to start with, but the fact that Joshua was able to take advantage of the situation and turn it into a plus just speaks to the fact that you need to have people on the team who know what they're doing, and you need to keep them involved through design, installation, and establishment. Anything else? I think we're about to the end of I really appreciate you guys sticking with it, and I'm happy to, based on your feedback, do a more focused presentation anytime. So feel free to send some suggestions on specific topics. Like I said, this was the money cage with the money flying everywhere, and hopefully you picked a bill or two out of the air and you put it in your pocket and you can make use of it later. So with that, I think, unless I see one last question or anything, we'll wrap it up. Is that okay, Heather, to go ahead and pitch it back to you?
Absolutely. So if anyone has a question, please do feel free. Get in touch with either myself or Mary. And I realized I didn't introduce myself at the beginning. I am Heather Seitz with Icon Engineering. And so I will put my email in the chat for everyone, just in case there are follow-up questions that didn't get answered. Quick reminder for everyone, yes, this will be posted on our CASFM YouTube channel. No, I don't have a timeline on when that will be because that's not my job, but I assume that it will be shortly. Also, CEUs will be mailed out. Again, I don't exactly have a timeline on when, but I assume that will happen pretty quickly. The next Lunch and Learn will happen on March 29th. 11 a.m., same bat time, same bat channel, from Dave and Laura with Mile High Flood District, and they will be talking about the district's effective partnering program. So with that, I would like to echo the many sentiments. Thank you, Mary, so much. This was an awesome and highly informative program. And thank you all to everybody who joined us today. This was absolutely much bigger participation, I think, than any of us at CASFM had envisioned. So again, just thanks to everybody for coming today. And I did just post my email in the chat. So if anybody does have further questions, feel free to shoot me an email. And with that, have a great afternoon, everyone.
Thanks, everyone. Really appreciate it.
Thank you all and take care.
Bye-bye.
Bye.